Hello and welcome back to Calculus 1. The lecture on today is the fundamental theorem of calculus. So, the fundamental theorem of calculus is going to have two parts to it. And one of them is going to be the part 1, which is what we already covered, and that is that the integral a to b of f of x dx is any antiderivative computed from a to b, which is f of b minus f of a. So this is the first part of fundamental theorem of calculus, which is how to compute the definite integral which gives us area under a curve. I already told you that this has huge application out there, from engineering to technically anything else, and you need to know how to compute the definite integral. Well, computers will be computing those for you. You just need to know how to set them up, I guess. Part 2 is theoretical and important to understand if you are interested in learning calculus. So part 2 gives the insight of and puts the whole Calc 1 into perspective. It says that the derivative of the integral a to x of f of t dt is f of x. So this, can you try and tell me what is this formula part 2 actually telling us? Yes. Well, that's one of the applications of it, but it's not that one. Yes. That's true. What does that mean? I think I'm thinking you're getting it, but what does it mean?
Just you can get, like, if you're looking for the original, you can get it, right? If you don't have it. So.
Yeah, but I do have it over there. It says lowercase f of t, lowercase f of x.
Maybe I don't have it.
You see both operators applied to f of t, and you're getting f of x. So what's happening there? They're technically doing what? They're canceling each other out. Yes. Derivatives and integrals are opposite operators. All right? So they're essentially canceling each other out. So if I am to write the derivative of, let's say, 3 to x of t squared dt, I can just write x squared. I don't have to compute anything. It's by the theorem immediately that. Now you could go and compute, and you will get x squared. So if you are to compute this, you will have the integral would be t cubed over 3 computed from 3 to x. And when you plug these values in, you get the derivative of, and then you plug in this, you get x cubed over 3 plus 9. And when you take derivative of this, you get x squared. So you could actually do the proof and show that that always happens. Because remember, the derivative of the integral a to x of f of t dt is going to be, now t is the main variable. When I integrate, I'm going to get f of t from a to x. And now when you plug everything in, you get f of x minus f of a, but f of a is going to be a number because you have a function and you plug in a value, like I had 3 before. and just get f of x minus 0, which is f of x. So the proof is very. Now my question to you is why? Why are derivative and integral opposite operators? Yeah, why? Yeah, why? Why are they undoing each other? Why they're opposite operators of each other? So you can integrate something and go back using differentiation. You can differentiate something and go back using the integral. Why? Why is that possible? What is the stuff that tells us, that shows us they're exactly the exact opposites of each other? What exactly shows us that these two operators are exact opposites of each other? I only had once a student answer this. I've been asking this question for 5 years. Only once a student answered this in class. Yes?
Is that the derivative is lowering your powers, or the integral is...
That's a consequence of something that I'm looking for. So you are on a track, but that's not the answer I'm looking for. What is telling us, what is the exact thing that is telling us that integrals and derivatives are opposites of each other, opposite operators? I can put on a final.
Just gonna like look at it first. Yeah, do you know? Is that what you're asking? Because you know calculus.
Just because, like, the derivative of the integral is like, it gets rid of the total set.
Yeah, but why does it work? I'll help you a little bit. Yes. So this is the help that I have for you. Can you decode now? Why are they opposites of each other? They're both limits.
But the one is computing as it goes to 0, and the other...
Okay, that has to do with it, sure. Yes?
I don't know what they said, but the limit of h to 0 is counting the distance away from 0, and then the limit from infinity. They kind of have to go towards each other.
Nope.
Yeah, they do.
When you're approaching 0, you are approaching it from two sides. When you're approaching from infinity, you approach from one side. Anyway, come on. Look, it's right there. Why are they exact opposites of each other? Because what? That would be why they are the same. They both have limit. Why?
Some derivative is difference.
Oh, there we go. So derivatives have subtraction and division. Integrals have addition and multiplication. You see multiplication and addition, and then there's your subtraction and your division. So they're formulas, and then also what you said regarding the limits, that the one limit goes to 0, the other one goes to infinity. So everything is opposite. Everything is opposite there, and they undo each other. They're completely opposite operators. Completely opposite operators. Yes. That's the stuff for the final.
So, wait, can we state it as simple as that?
That's it, yeah. There's nothing. I'm sorry if you're disappointed, but that's it.
No, but like that blob there, that's what I need to do.
Yes,
I
that's the
memorize
blob.
that.
Yes, that's what you're learning. It's fundamental theorem of calculus. Fundamental theorem of calculus. So one more time, this is theoretical section, guys. There is no learning new computational methods here or anything like that. In this section, we take the definite integral computation, and we take the other one here, and we have those two to create the fundamental theorem of calculus. And the part 1 tells us how to compute the definite integral, which is related to the area under the curve, which computes energies, money accumulation, amount of people that got infected by disease, amount of people that, I don't know, amount of rainfall in the area. All of these things are computed with integrals. And then also position, velocity, acceleration, and all that stuff in physics. And I already talked about the energy, but you also have stuff for electrical engineering, well, anything. So very important to know how to compute definite integrals. And then in part 2, you also have this formula which shows that integral and derivatives are fundamentally opposite of each other, which means that one undoes the other, and that formula summarizes all of that. So you can, if you have the derivative of the integral. Now, you are going to see spin-offs of this later in Calc 2. Right now, we show that the derivative of the integral is giving you function back. And we also see that when you use the first part of the theorem, since you are multiplying f of x times dx, you are getting area which is 2d. So that's for part 1. And for part 2, when you have the derivative of the integral of f of t dt, the derivative and integral cancel, which effectively is killing the dt part, and you end up with f of x, which is 1d. So one dimension. It's not area, because the derivative killed one of the two dimensions you were working with. So now, because you have a 2D case for the part 1 and 1D case for the part 2, later in Calc 2, you run into a formula for length of the curve, and you will see this a to b square root of 1 plus the derivative squared dx. Now, you are learning all the time that integrals compute area, but then very quickly in Calc 2, on day 3, you see this formula, and you go, what the hell? We're supposed to compute areas, not lengths of the curve. Length is just one-dimensional. But then when you roughly look, you see that the square and square root cancel. They don't cancel exactly because of +1. but roughly cancel. And then you see that you have integral of the derivative. Those two guys cancel, leaving just a function, which is 1D. So you can actually use the integral to compute one-dimensional length if you have the formula given this way, where the integral actually cancels with the derivative. And that formula can be upgraded into surface area of revolution and other things that you guys are going to learn in Calc 2, which starts in a week. So, not in a week, in 2 weeks. 2 weeks, yeah, 2 weeks, 2 weeks. On July 10th, Calc 2. And this is going to be formula that you're going to see on Tuesday. Right? So Tuesday. And it's going to be, I know. So, me neither. I love Calc 2. It's going to be a lot of fun. Is it afternoon or evening, Calc 2? 7 to 10? 7:30 to 10:15. Not a problem. 10 p.m. 10:15 p.m. So you're home by 11 latest. Like now you're still young at that point, right? That's when you start your night. You get home in time to study. All the studies exclusively done 11 to 3 a.m., right? 11 p.m. to 3 a.m., prime time. I used to have office hours at that time. All right, guys, that's it for the lecture. I hope you are not disappointed, but that's it, and let's do the review.